In a population of 2,000 individuals, 450 have the big B genotype, 695 have the heterozygous genotype, and 855 have little b genotype. So the first question is, how many big B alleles are present in this gene pool? Okay, so in this gene pool, there's 2,000 individuals, so there's actually going to be 4,000 alleles. And it's 4,000 alleles because each one of those 2,000 individuals is diploid, so they have 2 each. If we want to figure out how many B's there are, then we would look at the fact that we've got 450 individuals that have 2 copies each, and then we also have 695 individuals that have 1 copy each. Again, this is the big B individuals, this is the heterozygous individuals. So if we were to add that up, we get a total of 1,595 big B alleles. So I'm going to put that up here. Then if we want to calculate how many little b alleles we have in our population, for little b, we've got the heterozygous individuals, the 695 that have 1 allele each, and then we've got the little b individuals, and there's 855 of them, and they've got 2 copies each. So we want to add that up. So down here we've got 2,405 of these. And so we want to know, is the population in Hardy-Weinberg equilibrium? Well, to know that, we need to find the frequency of each allele, but since we figured out how many copies we have of each one, that's relatively simple. So if we look at capital B here, we know that we've got 1,595 out of a total of 4,000. So if we look at what that frequency is, it's 1,595 divided by 4,000. So that's going to give us a frequency of, it's going to round to about 0.4. If we want the frequency of little b, again, we're dividing this by the total number of alleles that we have in this gene pool. So we have 2,405 divided by 4,000, and this is going to round to about 0.6. So knowing that, we can calculate how many individuals do we expect to be big B. So if we start with that one, big B is going to be the frequency of that allele squared. So we would expect this to be 0.4 squared. So 0.4 squared is going to equal 0.16. And so if we take 0.16 and we multiply it by our 2,000 individuals, we would expect to get 320 individuals that would be big B. All right, so it's a bit different from the 450 that we have up here. If we wanted to look at the others, we could calculate how many of the heterozygous we expect to have. Those are 2pq. So the math behind that would be 2 times p, which is 0.4, times q, which is 0.6. So if we multiply that, we've got 0.48 is what we have. And so if we take our 0.48 and we multiply that by the 2,000 people that we have, we would expect that we're going to have 960 people that are heterozygous. And then if we looked at the little b, this is going to be q squared, or in other words, it's 0.6 squared. And so 0.6 squared is equal to 0.36, and 0.36 times 2,000 equals 720. So 720 people we would expect to be little b. So these numbers that we've calculated really don't match the numbers that we do happen to have in our population. So is the population in Hardy-Weinberg equilibrium? No, it is not.